Hi everyone, this is example 21. A standard short tube 100 mm diameter discharges water under a head of 5 meters. A small hole tapped into the side of the tube 50 mm from the entrance is connected with the upper end of a biometer tube, the lower end of which is submerged in a pan of mercury. Neglecting vapor pressure, to what height will mercury rise in the tube? Also determine the absolute pressure in kilopascals at the upper end of the piezometer tube. Coefficient of discharge is 0.82 for full flow. C sub V is 0.98 and C sub C is 0.62 at the point of tapping, or at the point where we have contracted section at 1. So this is the situation, and we're looking for H and the absolute pressure at 1, which is expected to be negative. So we write energy equation between points 1 and 2. So velocity head at 1, pressure head at 1, elevation head at 1, 0, because the datum is through 1 and 2. And equals velocity head at point 2, which is the only energy available at point 2, plus the head lost between points 1 and 2. So 0.62 coefficient of contraction is area 1 at the point of tapping over area 2, or area of the orifice, or this short tube here. So that means area 1 is 0.62 of area 2. So since by continuity equation Q1 equals Q2, and Q1 is area 1, 0.62 of area 2, area 1 is 0.62 of area 2 times V1, and Q2 is area 2 times V sub 2, we can cancel area 2, so that means V1 is 1 over 0.62 of V2, or 1 divided by 0.62 is 1.623 of V2. So V1 squared over 2G, we squared this divided by 2G is 1.623 squared divided by 2G. So V1 squared over 2G is quantity 1.623 squared of V2 squared over 2G. So 1.623 squared is 2.634 of velocity head at 2. So that's the value of velocity head at 1. So substituting the head loss from reservoir to 1 is 1 over C sub V square minus 1 times velocity head at 1. Remember the formula, 1 over C sub V square minus 1 times velocity head at 1. So it is equal to 0.04123 of the velocity head at 1. That's the head loss from reservoir to 1. And this is the head loss from 1 to 2. So head loss from reservoir to 1 is, because V sub 1 is 1.623, so 0.04123 times 1.623 of V2 quantity square becomes 0.1086 of V2 square over 2G, or velocity head, in terms of the velocity head at 2. So that's the head loss from reservoir to 1. So that if we write energy equation between the water surface or reservoir and point 1, then we have velocity head 0 in the reservoir, pressure head 0, elevation head is H for the water surface, then equals velocity head at 1. So see, velocity head at reservoir 0, pressure head 0, elevation head big H, equals velocity head at 1, pressure head at 1, elevation head at 1, 0, datum through 1, and head loss from reservoir to 1. So substituting the value of velocity head at 1, which is equal to 2.634 of velocity head at point 2 plus pressure head at 1 plus head loss from reservoir to 1, which is 0.1086 of velocity head at 2. So combining these two values, the head is 2.743 of the velocity head at point 2 plus pressure head at 1. Then V2 is 0.82, because coefficient of discharge is 0.82, and at section 2 it is flowing full, so that means coefficient of contraction is 1, so that the coefficient of velocity, which is C over coefficient of contraction, is just C. Again, 0.82 divided by coefficient of contraction at 2 is also 0.82, so therefore C sub V is 0.82 divided by 1, so 0.82. So V sub 2 is C sub V square root of 2GH. Then V square everything divided by 2G. So velocity head at 2 is 0.82 square times big H. After we square this, then divide it here. So 0.82 square is 0.6724 of H. So we substitute the value of velocity head at 2 into this equation here. So H equals 2.743 times 0.6724 of H plus pressure head at 1. So the pressure head at 1 is H minus 2.743 times 0.6724 of H, and that is equal to negative 0.844 of H. Having found pressure head at 1, negative 0.844 at of H, and H is 5 meters. So we sum up pressure from mercury surface here to point 1 to express the pressure head at 1 in terms of H also. So 0 minus 13.6 times gamma of water times small h equals pressure here. The pressure at this point, because this is filled with air, entrapped air, is also pressure at 1. So that's why we equate to pressure at 1. So the pressure head at 1, P1 over gamma of water, is negative 13.6 of small h. And it is also negative 0.8444 of big H, and big H is 5. So from here, we can now compute for H. It is equal to 0.3104 meters. Then the absolute pressure at 1, we compute first the pressure at 1 from this equation. So P1 over 9.21 is negative 0.844 of 5. So that means P1 is negative 41.42 kilopascals. The absolute pressure at 1 is gauge pressure, negative 41.42, plus atmospheric pressure, which is assumed to be standard, 101.3 kilopascals. So absolute pressure at 1 is 59.88 kilopascals. So that's the solution to this problem.